Welcome to the second part of the of lab one. So in the same data that I gave, the folder I gave you, you could see that there was another database in there called Wilson. So open a blank arc map, connect to that location, and then open the Wilson data. When you open that, there's a bunch of feature classes in there. So there's a police beat, there are schools, you have the census tracts, you have the Wilson crime. So what I want us to do is let's bring in the police beat, the schools, the census tracts, the crime, and then let's bring in the we don't need we actually don't need parcels. So bring in the streets, and then let's add in also the zoning. All right, so own you can hold down control and then select them and then add them to the map. Then what we are going to do is we are going to perform a little analysis with this data. Okay, so here let's take a look at the data. I can zoom in a little bit and then you can see this is the 1996 crime data for this particular locality. So what we want to do is we want to do some analysis to see the trend of crime they had within their jurisdiction. So I'm going to walk you through how we'll go about it. But first things first, let's save this map. So let's go ahead and save it. And then what you want to do with, you want to save it in the location that you are working in. So here I am on my drive. Let me find my location. Projects. Find my location where I keep my stuff. So you have yours. And then let me put it in here. So if you don't have an MSD folder, this is a good habit to have an MSD, and then you can keep all your MSDs in there. So here I'll call it Wilson crime analysis, and then save it. All right. So that will be that. So now let's take a look at the crime data. Let's open the attribute table, and then if you take a look at it, it gives you some information about the crime. So here we can see the month of occurrence, the day of the month, and then the day of week, and then you have the time of occurrence, and then you have the police beat in which it occurred, and then you have was it alcohol related, was it drug related? All right, so we can see certain things about the call. So here what we could do is we can start performing a couple of analysis. So the first thing I want us to do is let's change the symbology of the school. So as a crime analyst, our goal is to see how many crimes are happening in close proximity to schools. So here, if we have schools, right, look at the schools and then we can see the crime that is happening around them. Now, if you are in the local government, this could be of a worrying issue to you to see how many crimes are happening in this, let's say, in 0.2 miles from the school, how many crimes are happening. So that is a question the police chief wants to know. Maybe they have to increase up results. So let's try and answer a question like that. All right. So what we want to do is we want to go and use some of the other tools that comes with the technology. So here, if you have your toolbox open, so you go to your toolbox, open it up, and then what we want to do is we want to do proximity. All right. And there's a tool called buffer. So let's open up the buffer tool. And here we are going to buffer is just going to give you a ring around an area of interest. So my input is going to be the school because I want to draw a ring around the school, a 0.2 mile radius around the school, and see how many crimes fall within that 0.2 mile radius. So let's go ahead and then change this guy to be the schools. That will be my inputs. All right. And then what I'm going to do is my output, I want to ensure that my output is going into the database that I'm working in. So here I'm not in the London one, I'm now in the Wilson one. So I can go in and say school buffer, and then I'll put 0.2 miles, right? So I know I'm working in miles. All right. And then here, this is where you specify the distance. So here you see it's feet. So if we're going to say in miles, you want to say 0.2. You want to tell the software to change that and set it up that way. Okay. Now, when you do that, it's going to generate the rank around the school for you. So click on OK, and then let the tool run. And then when it's done running, it's going to add the rings around the school for you. So now you can see that we have the rings around the school. Okay. So now that we have the rings, we can now ask the question, how many of the rings happen around, how many crimes actually happen in 0.2 mile radius from the schools? So if we want to do that, then we can now do a selection by location. So go to selection, select by location. What do I want to select? I want to select the Wilson crime. And then what will be the source layer? It's going to be the 0.2 mile buffer. So I'm going to change that and select this guy. And then I want to say what? Okay. And what it's going to do is it's going to highlight all the crimes that are falling in there. So now if the police chief was asking for set of data, then this is the data we are going to give to the police chief to say that for all the jurisdiction within 1996, in the 0.2 mile radius, the total number of crimes we had was this. So you can see that you have what, 1,046 crimes that happen around the 0.2 miles radius of all the schools that we have in Wilson County. All right. So that answers the question. Okay, for that 0.2 mile radius. But what if he wants to ask, he wants to do you to get more information? So let's say we want to move, so clear selection. So go over here and clear selection. So now let's say we want to generate multiple rings. Now the buffer tool allows you to generate multiple rings. So if you double click on the multi ring, still I'm in the analysis toolbox proximity, my input is still going to be the schools, and then my output, I want to ensure that my output is going to my Wilson. So here I'm going to call it schools multiple, right? So just go school multiple, and then I can go say I want to do this time 0.3, 0.4, okay, miles. So I'll do that, and then when I come over here, this is where I'm going to go and put 0.3, and then I'll hit on add, and then I'll put another one 0.4, and I'll hit on add. And if I want to add stress, I can do that as well. And then don't forget to change the default unit. So change that default unit to, I'm measuring it in miles, and then go ahead and tell the software to run it. And when we do something like that, it is going to give us the figure that we are looking for. So it's going to give us the multiple rings at those interval. And then when we are done, we can specify the query to select. So now you can see how you generate a multi buffer. So this is your 0.3, and then this is your 0.4, and then you can see how they overlap. So for instance, if I want to select all the crimes that happen within 0.3, then I can use the same thing. I can go ahead and then use a select by location. But here in this time, what I wanted to show you is ArcMap or the GIS software always give preference to layers that was selected. So if you open the attribute table of the buffer and then you highlight the 0.3 ring first, and then you go to selection, and then you go to select by location. When you do that, and I want to select the Wilson crime, and then my buffer, multi-buffer is the one I'm going to use. Here you can specify that I want you to give me the calculation for the selected feature. So it's going to give you the results for only 0.3 miles. So if that's what we want to answer, we will check that, and then we'll hit on apply. And when we do that, we can see that it only gives us crimes that are within the 0.3 mile radius from the schools. So if I open the crime attribute table, I can get a figure to say I have what, 2,302 crimes that are within the 0.3 miles from a school. Now, if I want to do the same thing, but this time I want to find out from the 0.4, Then I'll switch the selection. I'll keep this parameter the same, and then I'll hit on apply. And the software is going to go in and then give me within what? Within that frame, only the ones that are within the between 0.3 and 0.4. So here, those are the figures that you are getting. You are getting 1,000. Those are the ones that are between 0.3 and 0.4. But obviously, if we want to select everything, then we can just say, I just want you to, I can remove this, and then I'll just tell it to say, I don't want you to apply a filter. Just do it for all, and then it will select all for them. So now your figures are going to be different based on whether you choose to only select a particular ring or you want to select everything else. So now you can see this is a simple analysis of spatial analysis that we are doing to see how crime in Wilson County actually operated within the 1996 radius. So let's go ahead and let's clear the selection on there, and we'll do one more. Let's take the buffer out. So if we take a look at the attribute table of the crime, we can see that we have days of week and then month. So for instance, we can select to say how many of this crime actually happened in the month of January, which would be 1. So to do that, we are going to open up the attribute table, and then we are going to expand the options and then go to select by attribute, and then here we are going to select by what? Month. So we scroll down scroll down and then say occurrence OCC month equals to get unique value and say 1, and then hit on apply. So here this is going to give us all the crime that happened within in the month of January. Okay, so we can repeat the same analysis to see, okay, yeah, let's say January people don't really get mad, so, but let's see December. What will happen in December? So open the attribute table, select by again, and then let's build the same thing to see if we have a higher one. So here we have 796. Let's see, occurrence month equals get unique value. Then let's go to why is it month? Data isn't correct. The date occurrence can be 30th month. There is no 30th month. So that is the data we are using. The sample data we have doesn't look right. Okay, so that one I guess will not be a good one. So let's build something for day of week, and then say probably 6, let's say 6th day of the week. We can also answer questions like that as well. So this is a basic queries to see, and then even we have time of occurrence. So if we want to see, let's say we want to build a query to say we want to select all crimes that are, let's say select all crimes. So time of occurrence should be oh, let me clear this. Time of occurrence should be greater or equal to, and then school starts at 7. Yeah, so school will start at, let's say 8, or time of occurrence should be now be less than 3. No, 015, not 013, 3, yeah, 15, so 3. So here we are building a query to say I want time of occurrence should be greater or equal to 8 a.m. and the time of occurrence should be less than 3. So here we want to see how many, no, that isn't right. Let me change this guy and put in. Okay. So we want to see time of occurrence is between 8 and 3. So if you do that, you can see that you have what, 2,702 crimes that happen within school time. So if one, we were checking on proximity of crimes, and then we can see, well, look at those ones, those are right next to schools, then there might be an issue that if you are looking for resource deployment, this could give you a heads up to say that, hey, those crimes are happening close to schools, and they're happening whilst kids are in school. So you might probably want to add up more security, more patrol to keep those school areas clean. So these are some of the analysis that we can do. We'll expand on this data. We'll do a couple more and add to it. So um, the initial space on canvas is not that much, so I'm requesting for additional space so I can add more videos to our class. So play with this data, test it out, and then see. Actually, before we go, let me try and expand this thing a little bit. So here we have Wilson. Let's uncheck this guy. So we can see we have the police beats. The police beat shows which police beat zones those crimes happening. What we can do is we can tell the police beat to calculate the number of points that falls within each of them, their jurisdiction. So here, if you open the attribute table, you can see that you have the police beat, and each of the beats have their own so you have 0 to 4. All right. So what we want to do is we want the beat to count how many crime falls within it. So we can do a map to see which beat has more crime. To do that, right click on the beat and then go to join and relate and then hit on join. And then here we want to do the spatial join as well, but we want to do it against the 2096 data. And then we want the summary one. And then here the output, let's just call it beats crimes. All right, so let's do that real quick and then hit on OK. And then what the software is going to do is it's going to generate a similar bit layer, but this time it will have a count field, and a count field will contain the amount of crime that falls within each of the jurisdictions. So if you scroll out to the right, you can see there's a count field over here. So what we can do is we can symbolize this map real quick using that count field, and that count field, so go to symbology. So I want to double click to go to the layer property, and then symbology, categories, and then I'll go on quantity, and then I want to map the quantity by the count. And then here you can see you have the different breaks. Now you can just take a look at it and see the ones that have high crime. All right. If you don't want the color, you can obviously come in here and then play with the colors and change it. And then if I'm going to use something like that, then I have to flip the colors, because the more red to the brain means high crime. And then if you don't want 5 breaks, then you can increase it to say I want 8 breaks, and then it will map it out for you. So here you can see now a simple map that shows where you have high crime. So you can see this particular beat is the one that has the most crime in Wilson County in the year 1996. So play with the data, we'll add more, we'll expand more to it, but this is pretty much how some of those spatial analysis questions are answered, and it all depends on what the audience want or what our question is. All right, so I'll see you soon.